A very good morning to one and all. I'm Balaji from SRMIST Vadapalni. I'm here to give you a presentation and comparative study of various machine learning and deep learning techniques for energy prediction and consumption using IoT modules. This is my outline: introduction, motivation, review of literatures, problem identification, objectives of the research, conclusion, and future works, reference. Introduction. Building Energy Management System BEMS has been a substantial topic nowadays due to its importance in reducing energy waste. Energy consumption problems are currently relevant topics all over the world. The rapid increase in energy consumption is observed in developing countries, especially challenge, strong challenges in energy consumption are uh, are to be brought up in enterprises in connection with the growth of production and equipments. Energy consumption by the machineries and industry plays a very vital role in setting up an industry. When an energy consumption is not considered as an important key factor, it may even lead to great loss for the industry. These are all the factors which motivated to proceed with this research topic. A smart energy consumption forecasting is very important, especially for buildings. Buildings' energy usage is increasing almost 40% of primary energy used in developing countries. Many countries are investing now in IoT to predict the future of energy consumption, mainly Western power. The need to achieve a balance between electrical energy production and consumption inspires researchers to develop forecasting models for optimizing an economical energy usage, yielding economic savings to optimize energy wastage, optimization of building energy consumptions. These are all my motivation factors. In a review of literatures, reference one, Louis M. Cadendo and et al. They have proposed four models: MLP, that is multiple linear regression, and a support vector machine, random forest and gradient boosting machines, among which GBM was found to be a best model with a 97% of accuracy. There are certain limitations too. Dataset for prediction model was only the weather data taken. In reference to Lai, Vexian, and et al., they proposed a smart energy theft system. They've used a multiple model of forecasting, which comprises of MLP, multiple layer perceptron, recurrent neural network, LSTM, long short-term memory, and gated recurrent unit. And that in these there is a limitation in it. These algorithms predicts and compares actual data just for detecting the abnormality in the energy consumption, and prediction was not implemented here. In reference 3, Ganit Abedi et al., they overcome energy prediction. They overcome with a few implementation of unidirectional EPS energy prediction systems, where they could have enhanced reliability, adaptability, energy efficiency, reduction number of communication protocols, improved control over home appliances. And the limitations include the challenges in implementing these modules. Reference 4, Abulaziz and et al. They proposed a genetic algorithm with LSTM. GA with LSTM was better performing than the conventional prediction methods. Limitations: it increased the computational complexity. Reference of 5, Taiyang Kang and et al. They proposed CNN, RNN, and a hybrid model, among which a CNN model greatly outperformed RNN and the hybrid model. The limitation of CNN is that it can predict energy for very short term, for a day alone. For a long term, it couldn't be applied. Reference 6, Algedro and et al. They identified a mixed architecture consisting of CNN and ANN. When compared to the other options such as ARIMA and classic ANN models, the suggested approach had great performance score. And the limitations, this mixed architecture is not implemented for general purpose. It is specifically implemented for a French energy grid. Reference 7, Nicholas et al., they proposed MLP scheme, MLP model, MLP enhanced with deep learning capabilities. Performance metrics included were RMSE and RMSE and MAPE, and the performance was better with traditional machine learning algorithms. Limitations, there was approaches, there were open challenges in processing the appropriate fixing up the appropriate parameters in MLP model. Number 8, reference Mel Ketiang and et al. Proposed three methodologies, um, SVM, ANN, KNN, out of which the performance of each method is compared, and SVM outperforms others, and there is a limitation to with SVM, which has taken 13 to 18 hours for prediction, and the computational hardwares used were highly powerful. Reference 9, Lei Xiong and et al., they proposed a new multi-algorithm fusion framework. MAF also provides more accurate estimate. Its accuracy beats existing fundamental algorithms because has a multiple model fusions. The complexity was one limitation with when implementing MAF, multiple algorithm fusion framework, where different algorithms were considered and fused by taking features from each algorithms. And reference 10, Tongley and et al., they proposed CNN with a bi-directional LSTM, and this methodology outperformed the traditional algorithms, and its limitation is that it results for hourly data set shows out for hourly data alone the performance was being proposed. 11, reference includes Tai, Young, Kim, and et al. They proposed a CNN LSTM technique which delivered a flawless prediction performance. CNN layer has a extract feature among which several variables that influencing energy consumptions uh, were being used for energy consumption, whereas CNN were being used for energy consumption, LSTM were being used for modeling temporal features. And the limitation included the potential limitation of CNN and LSTM model lies in trial and error to determine the hyperparameters. Hyperparameters are being considered as important parameter. Since trial and error method is implemented, this is considered as a limitation. Reference 12, Fethu, Men et al., they proposed CNN with a um, bidirectional LSTM. They suggested that the model proposed were outperforming with a good accuracy. Limitations includes higher computational and complexity while implementing this model. Problems identified: increase in demand for energy consumption, improper planning of energy production, variation accuracy factors, challenges in implementing deep learning algorithms in IoT environment. Objectives includes consumption and monitoring of energy, predicting the energy, comparing and analyzing, and developing new IoT models, ML based IoT models. Models implemented LSTM and KNN have been implemented from data sets, both are taken from the existing data sets and from the machineries through various sensors. And the performance metrics included here RMSE, MAE, root mean square error, MAE mean absolute error, R squared variance or mean absolute percentage thing, mean bias error, mean bias percentage error, and the graph for the model which I've taken into consideration is LSTM, and the graph for that is shown here. Conclusion: to compare and analyze the performance of each machine learning algorithm models have been done by considering certain performance metrics, RMSE, NRMSE, MAPE, to develop a new model for based on these outputs. A new model can be developed which performs in a satisfactory level in predicting our required energy. Comparison table of all the reference are proposed here. Uh, Model 1 included algorithm as SVM, ANN, KNN. Performance metrics, many were common. RMSE, NRMSE, and a MAPE were considered. Advantage: SVM has higher accuracy. Second reference, EWA, EWMA, and WCMA, and SCPAD and MAF were considered. These algorithms are being considered. Power loss parameter has been taken into account. MAF gives a more accurate estimation. Reference 3 combines genetic algorithm with LSTM. Advantage of GM: with LSTM better performs than the compared conventional schemes. Reference 4 CNN with RNN and the hybrid models. CNN was outperforming. Reference 5 ML, various ML algorithms have been proposed. Algorithm performs well, but process were a little bit complex. 6 includes KNN and LSTM. KNN outperformed well in finding the abnormalcy, and LSTM KNN implemented here for classifying normal usage and abnormal usage. LSTM outperformed energy prediction in predicting energy. Reference 7 mixed architecture consisting of CNN, ANN were being proposed. Out of it, mixed architecture outperformed RTE. In 8, ARIMA, MILP were being proposed. Total cost was reduced with 1118 percentage. Accuracy of the EMS performed was up to satisfactory level with R squared value of 0.98 and RMSE of 0.395. And these are the reference which have been taken. I thank the management for giving me this wonderful opportunity. Thank you all.